Wanted to provide a little homework help for the lesson 6-9 problems, pages 439 and 440. I've just selected 3 of these problems. So let's take a look. At this point, I've been forcing you basically to get the logs on the same side so that you could eventually use the properties. I really wanted to drill the use of those properties, especially the product and the quotient properties. Those come up quite a bit. But in this case, if you notice, something really should stand out to you on number 16, something that we've talked about quite a bit. It's right here. It says it equals the log base 6 of this negative number 8. Well, since the log of any number, no matter what the base is, the log of any negative number is undefined. That means that instead of going through a lot of work on this one, I'll save you a little bit of time. This is actually a no solution. Okay, just remember, log of any base of a negative number is undefined. Okay, so let's take a look at this one. Once again, I've been forcing you to solve these like we did on the previous test. So let me just go ahead and show you that method, and then I'm going to show you something else just for watching. I'll share with everybody eventually. All right, so what I've been doing is putting the logs together on one side because I'm trying to drill the properties, and I think we've had a lot of practice with the properties. And then we want to take this, and I'm trying to train you to take log form and change it to exponential. And so now we just multiply on both sides. Okay, well, let me just stop here and see if you notice something. Look at this and then look at the original equation. Do you notice it? There's something known as the log property of equality. And now that you've had a lot of practice with the properties and converting log to exponential form, now you can take advantage of this log property of equality, which basically says this. You have to have just 2 log expressions, one on either side of the equation. They have to have the same base. And if that's true, then you can essentially think of the equation as this. And that's what we have here. Sides are switched, but it's obviously the same thing. So that only applies to a log on either side. If you have multiple logs on either side, this doesn't work. This is the log property of equality. So going forward in problems like this, and you'll need to recognize when it's applicable and when it's not, you can avoid using the properties, changing over to exponential form. We're just going to solve this by making it a quadratic equation. So I'm going to add 7. I subtracted 10x, I add 7. Notice there's a GCF here, so I'm going to go ahead and factor that out. And I notice that I can factor more. And so my solutions for x are 4 and 1. So going back to my original problem, I just got to make sure that I don't end up with the log of a negative number with either one of these. And that can't happen here, obviously, because I'm squaring a number and then adding 1. And obviously I'm not going to get a negative result with either one of these values plugged in for x on this side. So I have 2 answers here. I could let x be 1, or I could let x be 4. And that's your answer for number 18. Okay, well, the same law that applies to equations, that applies to inequalities. Okay, so good news. If you've already done these, what I might call the old way, where we subtract, we want to use the properties, change it to exponential form, that's great practice. I think we've had enough practice. So what you can do now is take this inequality, since the bases are the same and it's like one equality opposite another, or one log opposite another log, then you can basically just take those expressions 7x minus 6 less than 4x plus 9 and solve for x. So subtract 4x and 6, and we end up with x is less than 5. But remember, we have to consider the numbers that could plug in for x to make these true. Okay, so let's see, up here, if I take 7x minus 6 and make it equal 0, I get x is greater than 6/7. Here, doing the same thing with 4x plus 9, I get x is greater than negative 9/4. Well, I hope you can tell that we got to pick the inequality that will, in conjunction with the numbers less than 5, will make both of these true. Well, obviously, this is another way of saying negative 2 1/4. We've still got negative numbers here that if we plug in for x, this is going to be negative. So I'm going to have to toss this one out, and I'm going to make a between inequality statement using 6/7 on the lower side. So this will be my interval notation. I'll have 6/7 on the lower side and positive 5 on the upper side. So this indicates all the numbers between 6/7 and 5. And then with an inequality, you can show it like this. It's another way of saying a between statement, the numbers between 6/7 and 5. All right, so hopefully that helps, and if you have any questions, let me know.